Okay, Meka, it's your first lecture, no?
Yeah, today is my debut.
Okay, so basically, I'll tell you the brief thing that we follow generally in class. First thing is, uh, how much do you know about gaseous state?
It's not done.
It's not
I'm not.
done. Okay.
No, no.
Okay. But you know the basics, PV equals nRT, ideal
Yes,
gases. That much you know, no?
yes,
Okay, that then it's okay. And do you know the graphs, basic graphs,
yeah.
straight line? You know
Huh.
that, huh?
Hmm.
Straight line, parabola, hyperbola, such type of graphs.
Yes.
Okay, very good. So now that's one thing that we'll be needing during this chapter. Second thing is, in this class, we follow that rule. If you have any doubt, without any hesitation, you have to ask your doubt. Don't put any filter between your mind and your mouth that I'm not knowing what will sir think. ऐसा कुछ नहीं करने का है. You have to ask your doubt if you're not clear about things. Okay?
Yes, sir.
Clear ना?
Sir,
हाँ जी भाई.
sir, I have a few doubts from पेज का empty paper.
तो वो क्लास के
तो
बाद कर लेंगे ना. क्लास के
सर
बाद
मतलब कहाँ भेजूँ, मतलब आपको ग्रुप
मेरे
पे
को
भेज दूँ?
व्हाट्सएप पे भेज देने का है. Whenever you are
Okay.
getting some doubt ना, तो send it to me, है ना?
Yes, sir. I'll send it on the group.
हाँ, व्हाट्सएप पे भेज देने का है ना. देन हो सकता है मैं उसी समय रिप्लाई कर दूं, हो सकता है थोड़ी देर के बाद रिप्लाई करूं, है ना? ओके.
Yes, sir.
ओके, चलो बाकी अभी कौन से लोग नहीं आए, कुछ लोग, दो तीन लोग अभी नहीं आ पाए, ठीक है. ओके, लेट्स स्टार्ट नाउ. सो बेसिकली if you say this chapter is called thermodynamics and thermochemistry, if you see the official syllabus of JEE Advanced, it says these many things. First thing is, अगर मैं अभी बोल भी दूं ये सब क्या है तो तुमको पता नहीं चलेगा, because you are going to learn these things. These are the new terms. But if you just understand the basics now, if I simply talk about what is thermodynamics and what is thermochemistry, if you just see this term now, thermodynamics, thermo stands for which term? If you remember, if you just listen the term thermo, what do you mean by thermo? क्या दिमाग में आता है?
हीट टेम्परेचर
हीट,
हीट
है ना? तो यहाँ से लग रहा है कि हीट जैसा कुछ तो यूज होने वाला है. एंड व्हाट अबाउट डायनामिक्स?
अरे फिजिक्स का वो एक सेक्शन है.
हाँ, बेसिकली मोशन से रिलेटेड है ना.
Motion.
तो whenever there is some motion we call it dynamics, है ना? तो ऐसा लग रहा है कि in this chapter we are going to deal with the motion of the heat or movement or transfer of heat from one system to another, है ना? ऐसा कुछ तो होने वाला है. Is it okay? When we are talking about thermochemistry, obviously we are learning chemistry, so we'll be talking about chemistry part. That means we are going to deal with the chemical reactions, है ना? So now overall, if I ask you what is thermodynamics and what is thermochemistry, one thing is very clear that we are going to talk about the heat, but in addition to heat, we'll be talking about all the energy forms which can be exchanged between a system and its surroundings. Okay. So whatever exchange of energy is happening between system and surrounding when it is undergoing some process or reaction, that is going to be the topic of discussion during the discussion of the chapter thermodynamics and thermochemistry. Any doubt up to this point? Clear now? So particularly when we'll talk about thermochemistry, that means when we'll talk about the chemical reaction, and during that chemical reaction which is undergone by a system, whatever energy transfer is being happening, uh, if whatever energy transfer is being done during the reaction between the system and the surrounding, that will be covered by thermochemistry, है ना? So when we are saying what is thermodynamics, it is going to deal with the exchange of energy between system and its surrounding in various forms including heat, है ना? So all sorts of energies will be seeing, but heat is going to be an important part of that. And when we are talking about thermochemistry, definitely we are going to apply thermodynamics only, but it will be applied to a system which is undergoing a chemical reaction and phase change also. That will also be covered in thermochemistry only. Like ice is melting and it is giving you liquid water. Liquid water is getting evaporated or it is being boiled to give you vapor phase water molecules. Hai na? So all these things will also be covered in thermochemistry only. Okay, so this is the part which we are going to talk about. But how to apply? Obviously, we are going to see laws of thermodynamics It starts with first law, then we have second law also, we have third law also, and there is a thermodynamics ka law which is called zeroth law of thermodynamics. Okay, so these four laws are there. Mainly during the chapter, you will see that even the syllabus is mentioning first law and second law only. If you see first law of thermodynamics, it is mentioning, and the second law of thermodynamics, it is mentioning. So mainly we are going to deal with first and second law of thermodynamics, but we'll talk about a little bit about the zeroth law and third law. एक एक लाइन की कहानी होगी वो, उसके बहुत डिटेल में जाने की जरूरत नहीं है. As you can see, it is not even mentioned in the syllabus, है ना? That's one part. Second part is when we'll be studying this chapter ना, पहले तो आज का class तो will be covering the basic terms which you are going to frequently use during the lecture, okay, during the chapter. तो वो करने के बाद my pattern of teaching is I'll be talking about first law obviously initially, and then we'll be applying it to a reaction uh, to a system which is undergoing some process, like gas is expanding, gas is being compressed, or some gas is in the closed container and it is being given some heat also, you know? So all those sorts of cases we are going to cover during the first law. But after that, I'll start applying that learning of first law into chemical reactions also, and that I'll call thermochemistry. So first we'll be having first law of thermodynamics applied to a system which is undergoing some process. Then I'll be talking about first law of thermodynamics applied to a system which is undergoing some reaction or phase change. Second part. Then I'll talk about second law of thermodynamics, and that we are going to cover with the system which is undergoing a process or even a reaction also. You know? So that will be the flow of our chapter. Okay. So in this part, first we need to understand that whatever laws of thermodynamics we are going to apply, where we can apply this laws of these laws of thermodynamics. So it is very clear that if you want to apply the law of thermodynamics, it will be applicable to the system which is already at equilibrium, or if it is moving from one state to another state, or if it is undergoing some process, then it is going from one equilibrium state to another equilibrium state. Is it okay? Clear? So if the system is not at equilibrium during the process, then we'll say at that state, in that state, you cannot apply the thermodynamics or the laws of thermodynamics. Is it okay? Clear a point? Now, when I say equilibrium, what does it
Sir?
mean? हाँ जी, बोलो.
सर वो मेरा नेट चला गया था, आपने अभी कौन सी लाइन बोली?
मैंने बोला कि whenever we'll try to apply the thermodynamics or laws of thermodynamics, na, it will be applicable to a system which is at equilibrium, or it will be applicable to the system which is undergoing some process, but in that process it has to go from one equilibrium state to another equilibrium state only. Okay.
Okay, sir.
Intermediate states
Yes, sir.
can be non-equilibrium also, but still it has to follow that initial and final must be at the equilibrium state. Okay, when I say Saran, when I say equilibrium state में होना चाहिए, तो during the process, we are not talking about only energy, only heat का exchange. It can be some exchange, है ना? So now, when I say it is in equilibrium state, definitely it cannot exchange the energy, है ना? But you can have a case where equal amount of energy is going from system to surrounding, and at the same time, surrounding to system is also some flow of energy is happening, and that can also be possible. Even then, it is at equilibrium. Is it okay? So, in one form, system can give the energy to surrounding, and in another form, system can receive energy from the surrounding. Even then, we'll say it is at equilibrium. So, that type of processes we are going to do. And I told you, it is possible that during the process you can have exchange of energy in various forms, and system may or may not be at the equilibrium state also, है ना? So those kind of things we are going to cover, and we obviously will go in detail, then you'll understand it more, है ना? Now when I say equilibrium state, what does that mean? If I say equilibrium state, it means three types of equilibrium. One is thermal equilibrium. What does that mean? Temperature of system must be we'll say constant, or it should be equal to the temperature of the surrounding, है ना? Second is mechanical equilibrium, or I'll say constant लिखने की बजाय better term will be it should be equal to temperature of the surrounding, है ना? Then we are saying it is in equilibrium. Mechanical equilibrium, net force on the system should be 0. And third is chemical equilibrium. There is a chapter called chemical equilibrium, which we are going to study after thermodynamics and thermochemistry. So in that chemical equilibrium, the net chemical composition of the system should be constant. It should not change. Net chemical composition of system must not.
So what is chemical composition?
Like if some system is undergoing some reaction in which H2 and O2 is going to be consumed and H2O is being produced. So at a particular moment, if you see that in the next moment, the composition, that means the molar ratio of H2O2 and H2O has stopped changing. You have got a fixed moles of H2O2 and H2O, then you will say it has reached at the equilibrium. Okay. But during the process or at a particular moment, if you see that the next moment the molar ratio of these three gases or the moles of these three gases are changing, then you will say that chemical composition is changing, and that's why the system is not at chemical equilibrium. Okay.
Oh,
But if I'm having a system which is not even undergoing the chemical reaction, then its composition is already fixed. So it is always at the chemical equilibrium, you know, because it is not undergoing any process. But even if a system is undergoing some chemical process or chemical reaction, it is possible that it will reach to a composition which is not going to change in the next moment, you know? And that state will be called the state of chemical equilibrium. Is it okay? तो इस पे पूरा चैप्टर ही जो अपने को पढ़ना है. हाँ जी.
Sir, in mechanical equilibrium, what
Yeah.
type of net force are we talking about?
Net force means mechanical force. Is like some piston is there. If it is having a mass, so mg force will be like if I'm having a system, if I'm having a gas and there is a piston over it, there will be some atmospheric pressure, there will be mass of piston. All those things are applying some force on the gas, है ना? If
Okay,
gas ka pressure is handling that much of force going downward, then we'll say it is at mechanical equilibrium, hai na? It is not moving.
Okay,
If it
sir.
was expanding and then it reaches a state where the piston is not moving, hai na? Then the net force on the system is 0, hai na? That's why it is not moving. Otherwise, it will start moving.
So
Yes, sir.
basically any external force.
Any external force. So net external force on the system should be 0. Obviously, we are talking about external forces, hai na?
Yes,
When
sir.
we
So
say net force on the
point,
system, it is always net external force. है ना? हाँ जी.
yes, sir. So after that point, no more compression or expansion can take
हाँ,
place.
so at that point, we are ensuring that there should not be any change in the volume of the system because there is net force is 0, and that's why there is no further compression or expansion.
Okay, sir. Yes.
चलो. तो now basically इसमें देखोगे कि if we take which is the normal case in chemistry, physics में तो जाके वो piston का mass भी दे देंगे, but right now we are going to deal with most of the time that piston will not have any mass. Assumption है, hypothetical assumption है. But if you are dealing with a system which is having a massless piston, then only atmospheric pressure is applying some force, है ना? And if that is equal to the pressure of gas, then it will not move, है ना? Piston will not move. So normally you will see if we are using massless piston, which will be mentioned in the question. Normally यही assume करके चलते हैं. So if massless piston is there, then if the atmospheric pressure is same as the pressure of the gas, then it is at mechanical equilibrium, है ना? या फिर मान लो किसी मूवमेंट में बराबर नहीं भी था तो मैंने इसको होल्ड किया हुआ था, इसको somehow होल्ड किया हुआ था. Even then the net force is 0, then only it is not moving, है ना? Is it okay? Any doubt? बढ़े आगे? चलो, now as I told you, बार मैं ये word system, surrounding use कर रहा हूँ. So we are going to deal with such type of terms very frequently. So आज के class का पहला session, obviously after this definition and all those things, will be based on some important terms which you are going to frequently using during the chapter, and that's why we'll start with the system and surrounding itself. When I say system and when I say surroundings, what do you mean by system and what do you mean by surrounding? And be very careful while choosing your system, because that will give you the direction in which you can do the calculation. Okay, so when I say system, whatever part of universe is under consideration, it can be a bottle filled with water, it can be the complete room in which bottle is placed, it can be the complete city in which that bottle is placed, है ना? Whatever part of universe we are choosing under which is under consideration, on which we are trying to apply the thermodynamics or the laws of thermodynamics, that will be called our system. And the remaining part of universe is called its surroundings. Okay, clear now? So if I say I'm having a gas filled inside this container which is having a piston, and if I say this gas is my system, if this gas is my system, we'll say it is definitely the remaining part of the universe. मेरा रूम, तुम्हारा रूम, दिल्ली, बैंगलोर, यूएसए, सब कुछ यूनिवर्स के रिमेनिंग पार्ट में आ रहा है, and that's why that will be called the surroundings of the system. नॉर्मली सराउंडिंग्स का मतलब हम लोग वैसे प्रैक्टिकली इमीडिएट सराउंडिंग की बात करते हैं. लाइक अगर मान लो मैंने यहाँ पर एक गैस स्टोव का बर्नर ऑन कर दिया है, तो इसका इफेक्ट वैसे तो पूरे यूनिवर्स में होने वाला है, बट वी सी द इमीडिएट इफेक्ट इन द रूम इटसेल्फ, है ना? So practical surrounding can be having a finite size, but if I'm talking about theoretically what is surroundings of a system, the remaining part of the universe is theoretically called the surroundings of a given system. Is it okay? When we are choosing system, our system on which we are trying to apply the thermodynamics, it can be a chosen mass, it can be a selected mass, or it can be a selected volume also. मान लो, if I am choosing a system, I am saying whatever is inside this container, ये पूरा इतना container में whatever is there, that is my system. Am I choosing mass or am I choosing volume? If I say whatever is present in this container,
volume.
we have selected only volume, है ना? हो सकता है mass escape कर जाए, हो सकता है mass enter कर जाए ना? That means we are choosing volume, so that is called control volume system, है ना? If a given volume in universe is selected as system, then it is called a control volume system. Okay, वैसा ही मान लो I'm having a system, a gas is placed inside this container with a movable piston, and piston is going out, and I'm saying it is having 2 moles of gas, and then I say the 2 moles of O2 gas is my system. Then I have selected mass or moles, है ना? हो सकता है it can have a greater volume, it can have a less volume. So we are okay for the variation of the volume, but we are not okay with the variation of the number of moles or the mass. And that's why such type of system, if we are saying this is the system, then we'll say if a given mass or moles in universe is selected as system, then it is called a control mass system. Okay, normally what happens na, हमारे लिए देखोगे generally will be choosing control mass all the time. Sometimes you can also choose control volume, and sometimes both can be same also. Like if I'm having a rigid closed container which is having some gas, then it is control mass as well as control volume, है ना? It is not changing its volume, it is not changing its mass. Okay, and in that case you can have control mass as well as control volume system. But sometimes you can have a different kind of thing, like you can have a control volume system in which gas might be escaping from the system, or gas might be might be entering into the system. But you can have a control mass system. So normally you will see that in our course this will be the frequent assumption. Okay, any doubt up to this point? Any doubt? चलो, तो ये था हमारा सिस्टम. नाउ अभी जस्ट मैंने तुमको दो सिस्टम दिखाए. One was having open container, another was having a movable piston. In both the system, if you see, in one case I have told that mass might enter into the system, mass might be escaping from the system, and that means it is an open system, है ना? Mass can be transferred or mass can be exchanged between the system and the surrounding. That type of system is called open system. तो ये सब कहां से आ रहा है? ये आ रहा है कि सिस्टम और सराउंडिंग के बीच की बाउंड्री कैसी है ना. सो लाइक अगर मैंने बोला कि दिस इज माय बाउंड्री, इफ आई एम ड्राइंग द बाउंड्री, if I say this is my boundary, so some part of it is closed, real, but some part, this part of the boundary is actually imaginary, है ना. It is not a real boundary. There is no ढक्कन उधर, कोई भी कैप नहीं है, कोई पिस्टन नहीं है ना. And that's why we'll say if I'm having imaginary boundary between system and surrounding, definitely the system can exchange mass with the surrounding because it is having that imaginary part of the boundary, and that's why that type of system will be called an open system. So if I am having an open system, the system and surrounding can have exchange of mass as well as energy, है ना. Is it okay? So now, based on the type of boundaries present between the system and surrounding, you can have three types of systems. One is open system, in which you can have mass as well as energy exchange between system and surrounding. But if I'm having a closed system, it's like open system जब बोला ना, तो it is like एक खुला डब्बा है. This is open system. When I say closed system, इसका मतलब है डब्बा तो बंद है, but there is no insulation, so energy can be exchanged, है ना. But mass cannot be exchanged, है ना. If I have to do mass exchange हो सकता है कि नहीं, तो we'll say this cannot be exchanged. Mass exchange is not allowed. But when I say if I'm having an open system, we'll say यहाँ से energy भी जा सकता है, आ सकता है, and mass का भी exchange हो सकता है. That is also possible. But if I'm having an isolated system, neither mass nor energy can be exchanged between the system and surrounding. एक practical example देता हूँ. If I'm having a system, मैंने डब्बा तो बंद रखा ही रखा, साथ में इसको पूरी तरह से insulate कर दिया, and we are not surrounding का or any external agent is not interacting with it, then it is called an isolated system. Is it okay? Any doubt? So if they are using word like an isolated system or container, that means we'll say there is no energy exchange between system and surrounding. But if we are having an open system or a closed system, energy may be exchanged. We are not giving the guarantee, but energy may be exchanged between system and surrounding. That provision is present there. If I'm having a closed system, definitely mass will not be exchanged between system and surrounding. If I'm having an open system, it is possible that even the mass might be exchanged between the system and surrounding in addition to the energy. Any doubt?
So most questions में कौन सा system देते हैं वो?
नहीं, वो डिपेंड करेगा. कई बार हम लोगों के पास क्लोज सिस्टम रहेगा, कई बार ओपन सिस्टम रहेगा. आइसोलेटेड रेयरली होता है, क्योंकि वी आर गोइंग टू टॉक अबाउट थर्मोडायनेमिक्स, है ना. वी आर गोइंग टू टॉक अबाउट द एनर्जी एक्सचेंज बिटवीन सिस्टम एंड सराउंडिंग, एंड दैट्स व्हाई इफ आई एम हैविंग एन आइसोलेटेड सिस्टम तो कोई एनर्जी एक्सचेंज नहीं हुआ, तो फिर व्हाट विल यू स्टडी, है ना. बट वहां पर एक इंपॉर्टेंट पार्ट आ जाता है कि इफ दे आर यूजिंग द टर्म आइसोलेटेड सिस्टम, दैट मींस दे देमसेल्व्स आर टेलिंग यू कि देयर इज नो एक्सचेंज बिटवीन सिस्टम एंड सराउंडिंग, तो सिस्टम की एनर्जी विल बी कांस्टेंट और इट विल बी कंजर्व्ड, है ना. इज इट ओके? बट अदर देन
आइसोलेटेड सिस्टम वाला पार्ट फिजिक्स में पढ़ाते हैं?
कौन सा
आइसोलेटेड सिस्टम वाला पार्ट फिजिक्स में पढ़ाते हैं क्या?
दोनों में, ये चैप्टर कॉमन है दोनों में, ठीक है. थर्मोडायनेमिक्स इज कॉमन इन फिजिक्स एंड केमिस्ट्री. कुछ कुछ क्वेश्चंस में यहाँ आइसोलेटेड सिस्टम दिख सकते हैं, बट मोस्टली यू विल बी डीलिंग विद ओपन एंड क्लोज सिस्टम. ओके. Okay. Now, once we have decided that what is our system and whether it is open, closed, or isolated, obviously we are going to study some of the properties of the system. So, what are those properties of the system? We call them that whatever parameters, mathematical parameters, are going to define the state of a system. Like if I'm having a closed container with a piston and that container is having a gas, what is its temperature? What is its pressure? How many moles of gas is present? है ना? What will be the what is the volume in the current state for the given system? So whatever type of thing we are understanding or we are considering during the study of the system, na, all those mathematical parameters or mathematical quantities which are defining the state of the system are also called the properties of system. Okay, so when I say properties of system, what does it mean? It means it is going to be the set of parameters which are characterizing the system, and ये set of the properties है ना, इनको मिला के at a given instance, like मैंने तुमको एक system दे दिया, that means I am having a gas in a given state, its mole is given, its volume is given, its temperature is given, its pressure is given. ये सब अगर दे दिया है मैंने ना, so that means we are saying that at that given instance, this is the state of the system. Is it okay? Clear na? Okay, now I'll ask you one question. मान लो I am having a gas which is at 100 degrees C and it undergoes some process through which its temperature is changing to 120 degrees C. What is the change in temperature? 100 degrees C was the initial temperature and the final temperature after a process becomes 120 degrees C. What is the change in temperature? 20 डिग्री सी. बोलते रहो, इसमें कोई दिक्कत नहीं है. You have to express yourself, है ना. So it is 20 degree C, but while answering that, you have not asked me what kind of process was undergone by the system, है ना. You have not asked me the detail, है ना. So by simply knowing the initial and the final state, ना, by simply knowing, नहीं कन्वर्ट करने की जरूरत नहीं विमान. मैंने एक चीज शायद स्टार्ट में तुमको बताया होगा, difference of temperature in degree C or in Kelvin are same always, है ना. Even if you convert 100 degrees C to Kelvin, it will become 373 Kelvin, है ना. And if you convert 120 degrees C, it will become 393 Kelvin. What is the difference? Even in Kelvin, it is 20, है ना. So difference in temperature in Kelvin and degree C is same. Temperature in Kelvin is not same as temperature in Celsius, but difference of temperature in Kelvin and difference of temperature in Celsius will have the same value. Is it okay, everyone? Clear ना? हाँ, मतलब जहां भी टेम्परेचर यूज करेंगे विल बी टेकिंग दैट इन केल्विन, बट वेरेवर विल नीड ओनली द डिफरेंस इन टेम्परेचर, वी डोंट हैव टू कन्वर्ट दैट. वी आर वेस्टिंग आवर टाइम because ultimately we are going to get the same answer, है ना. Okay, so now what I was saying, while answering this question, you have not asked me what type of process the system has undergone, because I have given you the initial and the final state of the system, है ना. So because of that, the properties are also called state functions, because if you want to know the change in those properties, you just need to know the initial and the final state. It doesn't, you don't have to know the details of the process if you know initial and final state. ऐसा नहीं कि कहा गया कुछ बताया नहीं और फिर मैं पूछ रहा बताओ चेंज क्या होगा. मतलब मैं इतना बोल दूं कि 100 डिग्री सी पे द सिस्टम वाज देयर एंड इट हैज अंडरगोन सम प्रोसेस, बताओ फाइनल टेम्परेचर क्या होगा. इन दैट वी हैव ओपन, मतलब वी हैव केप्ट इट ओपन की अभी मुझे पता ही नहीं कहां तक गया क्या हुआ. बट इफ आई गिव यू, चलो मैं टेम्परेचर डायरेक्ट नहीं भी दूं, मैं तुमको बोलूंगा 1 मोल ऑफ गैस था which was having initial pressure इतना, initial volume इतना और final pressure and final volume इतना हो गया. Even then we can calculate now what was the change in temperature, है ना. Is it okay? Can we do that? मैंने P1 V1 दे दिया, P2 V2 दे दिया, and then I have asked you what was the change in temperature if we are considering ideal gas equation. So you will calculate ना, initial temperature was P1 V1 by NR, है ना. Final temperature will be P2 V2 by NR, and then why after taking the difference you can get the change in temperature.
Sir, but इसमें तो the change in temperature would be zero, right?
Why change in temperature will be zero?
So because this is only applicable for isothermal process now.
हाँ फिर से
So like PV is equal to constant, so should it be
constant
T
नहीं
is
बोला
constant?
मैंने बोला I have given you these two terms, so I can write na T1 is P1 V1 by NR. I am not telling you that it is constant. I have not kept P1 V1 equals P2 V2. ऐसा मैंने नहीं बोला.
अच्छा, okay, understood.
I am simply applying that T1 will be this much and T2 will be this much, है ना. And if they are asking you what is the difference of temperature between final state and initial state, we will write this one, है ना.
Yes.
Okay. So even if I am knowing the initial and final pressure and volume along with the moles, I can get the difference in temperature, है ना. But even if we are knowing these details, you have not told me what kind of process the system was undergoing. Even then, I was able to get the difference in the temperature, है ना. And that's why temperature will be called, it is a property, and that's why it is also called a state function or state variable, because change in their values require only information about the initial and final state and not the path or the process, detail of the process followed. Is it okay? There are two things, there are two terms which are actually called non-properties or path functions or path variables. Those terms are heat and work. जिसकी डिटेल हम लोग बाद में करेंगे obviously. What is when we say heat, what does it mean? When we say work, what does it mean? We'll talk about that. But right now I'm just giving you an information. If they're asking you what is state function or which of the following are state function or state variables, which of the following are non properties or path function or path variable, we need to know in our syllabus. These are the two terms which will be called non-properties or path function or path variable. इसकी detailing बाद में करेंगे. Just I was defining state function or state variable, and that's why I've given you this information. बाद में इसको समझेंगे theoretically भी, numerically भी, कि what is heat, what is work, and why these two terms are called path functions or path variables. Okay? Is it okay? बढ़ जाएंगे. अब यहाँ पे एक कहानी ये है कि मैंने तुमको अभी जस्ट बोला, अगर मुझे इनिशियल प्रेशर एंड फाइनल प्रेशर बता दो, इनिशियल वॉल्यूम और फाइनल वॉल्यूम बता दो, तो आई कैन गेट द डिफरेंस इन टेम्परेचर. तुमने मुझे टेम्परेचर दिया नहीं, आई वाज एबल टू कैलकुलेट दैट, है ना. इज इट ओके? इज दैट ओके? Just by knowing
Yes.
initial pressure and volume along with mole, I was able to get the initial temperature. Now there is a theory which talks about how many properties along with moles you need to get all the other properties of that same system at the given instance, है ना. तो in that जो अपने syllabus में है ना, वो part ये है कि if I am dealing with a system which is having one phase and one component only, I am having a system which has only one phase and one component. For that system, if you just know two properties along with mole, na, you can define all the other properties. Like in this case, I was given pressure and volume along with mole. I was able to get the temperature. बाद में हम लोग देखेंगे कि I can also get the internal energy of the system. I can also get the enthalpy. These are the terms which you are going to learn in this chapter. But I can calculate enthalpy of the system. I can get the entropy of the system. I can get the free energy of the system. All those properties we can calculate. Okay. So the theory talks about the number of phases and number of components. So now first we'll understand when I say what do you mean by component and what do you mean by phase. Okay. So first point is I'll be giving you the detail. मान लो अपने पास liquid water है. How many components we have? If I am having liquid water,
So hydrogen and oxygen.
nahi na. Are they different or they are combined already? When I
Combined.
say, if I say 18 gram liquid water, what is component in that system? It is H2O only. Hai na? You can't say hydrogen and oxygen. It is H2O. Hai na? That is a molecule. Okay. And how many phases are there? It is only liquid phase here. Is it okay? And that's why we'll say this is a system. If they're asking you how many components are there, we'll say it is a one component and one phase system. Is it okay? Clear hai? What is the chemical composition? If we are getting two types of composition, then we'll say it is a two component system. If I am having two types of phases, then we'll call it two phase system. So like, I'll give you another example. If I am having 9 gram ice floating over 18 gram water, liquid water. How many components we have? Component
One.
means chemical composition. That means chemical formula. Ice का formula क्या है? It is H2O only, है ना? And liquid water is only H2O, है ना? We'll say it is still having one component. But how many phases it has got?
टू फेजेस.
Two phases, है ना?
सर तो फेजेस में हम लोग स्टेट देखेंगे
हाँ.
और कंपोनेंट में कंपोजिशन देखेंगे.
Now one caution. Even if I am having two solids, na, if they are not in homogeneous mixture, then we'll say it is having two phases, even if both of them are solids. Like if I'm having graphite along with diamond, na, we'll say both of them are solids, but they'll be considering to have different phases. If two parts of your system are having some interface between them, then definitely they have got different phases, even if they may have same physical state.
सर बट
Like
डायमंड और
water के
ग्रेफाइट
ऊपर
में
केरोसिन डाल दो, water के ऊपर केरोसिन डाल दो. If it floats over water, I'll say both of them are liquid, but we'll say they are having two phases, है ना? दोनों
Sir,
अलग अलग
मतलब
है.
सिर्फ homogeneous को हम एक phase consider करेंगे.
हाँ, whatever in whatever part of system you are getting homogeneity, then it is the same phase. If you are not getting homogeneity, then it is having different phases. Okay. So I'll give you third example. Then you'll understand everything.
Sir, so alloys would be a one phase system.
फिर से
Alloys.
नहीं सुन पाया मैं. Repeat yourself. Ajay, your voice was not clear actually. Tell me again.
So वो बोल रहा है कि alloy should be one phase.
Alloy. हाँ, if it is in the homogeneous phase, then it is one phase only. Yes. Or if I am having, जैसे अभी मैं बता रहा हूँ, if I am having liquid coffee, how many components we have? One or many? How many components we have in liquid coffee? Definitely it will be many, है ना? Is it okay? it is having water, it is having coffee, it is having milk if you are giving it milk, it is having sugar. All of these are chemically different components, na? And that's why we'll say it is having multiple components. And how many phases it is having? One phase, na? It is totally liquid, na? So it is having just one phase. Now you have understood the component and phase, na? Any doubt?
No, sir.
Okay. So if I am having liquid water inside a closed bottle, which is also having water vapor, then how many components we have?
One.
One. क्योंकि
बॉटल
it
को
is
भी काउंट
H2O.
करेंगे क्या?
हाँ जी?
बॉटल को भी काउंट करेंगे नहीं ना?
नहीं, बॉटल को नहीं लिया मैंने सिस्टम. आई एम जस्ट सेइंग that liquid water along with water vapor is my system. है ना? Then we'll say कि my system is having one component, but it is having two phases again, है ना? Now understood na, number of phases and number of components. Okay, so I'll give you these examples I have already having in type before. Whatever I have explained na, it is written here only. So now एक theory है जो अपने काम बहुत आने वाला है, and that theory is if I am having a system जो कि तुम्हारे syllabus में है, most of the time we are going to deal with that system only. My system will have one component and one phase. Like if I am having 1 mole of O2 gas, it is one component and one phase system, है ना? For such type of system na, which is having one component and one phase, if you just know two properties along with moles, you can get all the remaining properties of the system. That means you can get the complete state of the system. Is it okay? Like I told you initially, if I'm having initial pressure and volume given na, अभी just किया था हम लोगों ने, I was just knowing pressure and volume along with mole, and I was able to get the temperature, है ना? I'll be able to get the enthalpy or the free energy or the entropy or the internal energy of the system. जो कि बाद में पढ़ेंगे what is that term. But we can get this term, all the other properties also. That means we can get the complete state of the system. Is it okay? अब ये हमेशा ध्यान में रखना क्योंकि बाद में conceptually if you are getting confused somewhere na, this sentence will be very useful. So I'm writing here, it is very important to understand that if I'm having a one phase, one component system, which will be the frequent system you are going to deal with in this chapter, then two properties other than moles, obviously, mole pata hona chahiye, and then in addition to that, we should know at least two properties, then we can completely describe the state of the system. That means we can know all the other properties. Is it okay? Clear na?
So what are these properties, the two ones other than moles?
Like I told you ना, बहुत सारी properties तो इसी chapter में पढ़ेंगे. Like there is something called internal energy, there is something called enthalpy, there is entropy, there is free energy. Other than whatever you have learned in physics and chemistry na, till now, refractive index, density, molar enthalpy, specific heat capacity, जितनी चीजें पढ़ते हो ना साइंस में, which can be used for a system, that is called property. Okay.
Yes, sir.
जितना फिजिक्स केमिस्ट्री में पढ़ने वाले हैं या पढ़ चुके हो ना, all those were the properties of the system, है ना? मैंने बोला this system is having this color, even that is a property. I'm having a substance which is having this much of refractive index, it is also property. I'm having a liquid which is having this much density is the property, है ना? Okay. System is having 50 kilojoule energy, that energy is actually internal energy of the system, that is also property. This much is its temperature, this much is its pressure, this much is its volume, this much is its molar volume. ये सब properties. Now we are going to see the types of properties, because if you see the syllabus का पहला point जो उन्होंने लिखा है ना, that is about something called intensive and extensive properties. उसके बाद state function जो लिखा है वो तो मैंने समझा दिया तुमको. So when we say properties, properties can be mainly divided into two parts. I'm not giving only these two types can be there, but properties can be mainly divided into two parts. One is extensive property, another is intensive property. When I say extensive property, what does it mean? It means if I'm having a property for which the value is depending on the size of selection in the system, then we are saying that it is going to be an extensive property. Like I have told you, I'm having moles, mass, volume, all these terms. I'll give you an example. मान लो कैसे identify करते हैं. So how to identify some property is extensive or intensive. तो क्या करने का है, मान लो this is a room or हाँ चलो room मान लो, this is a room in which air is filled, and what I need to do, I'll divide it into different compartments. They cannot have they must not have, or they can have equal or unequal sizes. It is not guaranteed that you have to take the equal size only. So मान लो I have divided it into 5 compartments, and if I am having a property X, and if someone is asking whether this property is extensive or intensive, what I'll do now, I'll find out the property ka value for this compartment. Assume that it is x1 for that compartment. It is having a value x2 for this compartment, x3 for this one, x4 for this one, and x5 for this one. And if you find that overall system का जो x का वैल्यू आ रहा है ना, that is equal to x1 plus x2 plus x3 plus x4 plus x5, then we will say X is an extensive property. Example, anything you can take. जैसे mass ले लिया. If I am having you are having your room ना, उसके different उस room को hypothetically, imaginarily different compartment में divide कर लो, and individual compartment के mass जो होंगे ना वो same नहीं होंगे ना. If you are having unequal size of compartments है ना, so they are not necessarily same for all the compartments if the compartments are not having equal size. And then if you add the all compartments ka mass, basically you are getting the mass of the room, hai na? And that's why we'll be saying that mass is an extensive property. While considering or while deciding whether a property is extensive or intensive, you need to take a homogeneous system. Okay? While deciding whether a property is extensive or intensive, consider the system which is homogeneous, and then only you can find out whether a property is extensive or intensive. Okay? We are saying take a homogeneous system. ऐसा नहीं कि heterogeneous ले लिया. So the important part is the value of property should be directly proportional to, and when I say directly, that means mathematically directly proportional to size of selection. That means you have doubled the size, then the property ka value will also be exactly doubled. It will not be 3 times or 4 times or 1.5 times. सिर्फ बढ़ जाना is not important. अगर तुमने size of selection को double किया है ना, तो property का value भी double होना चाहिए. मतलब 1/4 of the room में जितना mass है ना, half of the room में उसका exactly double mass होगा, है ना? Then only we are calling that mass is an extensive property. ऐसा नहीं बोला कि 1/4 of the room में mass जितना होगा ना, उसका 4 times या 5 times will be the mass of the half room, है ना? Then it is neither extensive nor intensive actually. Any doubt up to this point? Any doubt? फिर दूसरी प्रॉपर्टी ले लेते हैं, इंटेंसिव प्रॉपर्टी. So when I say intensive property, what does it mean? If I am having a property which has value independent of the size of selection in the system, that will be called intensive property. For example, I am taking a homogeneous system again, like a room filled with air. And I'm trying to find out whether a property Y is intensive or not. I'll again be taking the system. I'll be again taking a system which is having different size. I'm hypothetically dividing it into different size of compartments. And मान लो I'm having a property y which is having value y1, y2, y3, y4, and y5. And then if you get y of system exactly equal to y1 equals y2 equals y3 equals y4 equals y5, even if we have selected a different size of compartment, then we'll say y is an intensive property. Like you see temperature. When I say temperature, अभी आधे रूम का टेम्परेचर बोलूं या 1/4 रूम का टेम्परेचर बोलूं या फिर पूरे रूम का टेम्परेचर बोलूं. इफ यू आर लाइक विद एसी यू आर मेंटेनिंग इट एट 24 डिग्री सी, तो एक कॉर्नर का टेम्परेचर बोलूं या आधे रूम का बोलूं या 2/3 ऑफ द रूम का बोलूं या फुल रूम का बोलूं, इट विल बी 24 डिग्री सी ओनली, है ना. एंड दैट्स व्हाई वी आर सेइंग दैट टेम्परेचर इज एन इंटेंसिव प्रॉपर्टी. इज इट ओके? क्लियर है? So now two things are
Sir,
there. हाँ जी बोलो.
सर फिर ये प्रॉपर्टीज का चेंज क्या होगा फिर?
क्या चेंज होगा मीन्स?
मतलब सपोज इफ यू टेक एन एक्सटेंसिव प्रॉपर्टी
ओके.
और फिर डिवाइडेड बाय एन इंटेंसिव प्रॉपर्टी,
हाँ.
और उन दोनों का मतलब dy बाय dx टाइप किया तो क्या होगा?
तो dy by dx पे तो बाद में जाएंगे, पहले तो रेशियो की बात कर लेंगे. तो वन थिंग इज इफ आई एम हैविंग सम एक्सटेंसिव प्रॉपर्टी ना, तो वैल्यू ऑफ एक्सटेंसिव प्रॉपर्टी आई टोल्ड यू दैट इट इज मैथमेटिकली डायरेक्टली प्रोपोर्शनल टू size of selection or the size of compartment you have selected in the system. Okay, but if I'm talking about intensive property, if I'm having some intensive property, value of intensive property is independent, है ना? This doesn't depend on size of selection, है ना? Now, if someone is asking you, मेरे पास दो extensive properties है, will the ratio of those extensive property be depending on the size of selection? Like I'll give you an example. मान लो अपने पास एक प्रॉपर्टी जो है ना वो Z1 है and that is 3 times of x where x is the size of selection. Okay, चलो इसको Z3t बोल देता हूँ ऐसा. And I am having Z2 which is 5 times t. If I ask you Z1 by Z2, will it be depending on t? Will it be depending on t?
No, sir.
No,
No, no, it is simply 3 by 5. That means if I am taking the ratio of two extensive properties, na, it will become independent of the size of selection in the system. Na? And that's why if they are asking you what the ratio of two extensive property, you will say that it will always be an intensive property. And that's why if you see now, when I have written intensive properties ka example, it is density. Density is what? Mass upon volume. Mass was an extensive property. Volume is an extensive property, and ratio of these two properties will become an intensive property, that is density. या फिर if I am saying volume is an extensive property, mole is an extensive property, volume per unit mole, that is molar volume, it will be an intensive property, है ना. तो मान लो कहीं molar volume यहाँ तो लिखा नहीं है, I'll write that. मान लो molar volume लिखा है, that will be an intensive property, है ना. तो यहाँ पे एक important part आ गया. And while doing that ना, you have to follow these two lines only. That intensive property का value doesn't depend on size of selection in system, while the value of extensive property is directly proportional, mathematically directly proportional to the size of selection in the system. Any doubt up to this point?
एंड सर एक्सटेंसिव अपॉन इंटेंसिव किया तो क्या होगा?
तुम बताओ क्या होगा, जरा देखो. Numerator is proportional to size of selection, denominator is independent, so overall value is also size proportional to size of selection only, na? Clear, na?
Yes sir.
And that's why it will remain extensive. So extensive upon intensive will become extensive. Just wait for 1 minute, someone has come. Yeah. So basically whatever we have learned so far, ना एक बार उसकी थोड़ी practice कर लेते हैं. So like I'll be giving you some of the questions. Jara try करो, if you are getting these terms, these things right, then we have learned the concept.
सर वो लोग अगर वो लोग ऐसे क्वेश्चन नहीं पूछेंगे ना कि अगर एक्सटेंसिव और इंटेंसिव का ऐड किया तो क्या होगा?
देखो ना आगे पूछूंगा ना मैं, क्यों घबरा रहा है? We'll be having those
पूछते
questions.
हो भी पूछते.
मैं अभी
सर वो
पूछने वाला हूँ.
TWT में पूछा था क्वेश्चन,
अभी करने वाले हैं. देखो तो पूरा टेबल ही करवा दूंगा मैं तुमको. चलो जी. फर्स्ट फ्यू फिल इन द ब्लैंक्स. फिल करो जरा. फर्स्ट में क्या फिल करूं यहाँ पे? व्हाट टू फिल हियर?
इक्विलिब्रियम.
वेरी गुड. सेकंड में यहाँ पे और यहाँ पे
वहां पे भी इक्विलिब्रियम.
अगेन इक्विलिब्रियम स्टेट टू इक्विलिब्रियम स्टेट, है ना? Okay, next answer I want from Athar. You tell me the answer of the second question. What to fill here?
Yes, 1 second. Sir, is it open system?
Very good. Marius, tell me the answer of this part.
Closed.
Very good. Okay, next question ka answer I want from chalo Udayan, tell me the answer of this part.
Isolated.
Very good. Okay. Let's see 2, 3 more questions. Third question.
Sir,
Yeah.
in the second question, the second part is closed, right? So why is it closed, sir?
Closed means it is not allowing the exchange of mass, है ना? Energy can be exchanged, but mass is not being exchanged, है ना?
And isolated is when energy is also
Energy as well as mass cannot be exchanged, है ना?
okay.
Neither energy nor mass, है ना? Okay. Now tell me here. Will tell me Niranjan.
Yes sir.
Haji?
1 second sir, I'm reading.
Yeah.
सर क्वेश्चन नहीं समझ आ रहा.
Okay. कोई और बताएगा? रेहान, can you tell me the answer? Rehan. Okay. Udayan has given the answer, right answer. Rehan, you there?
Yes, sir. I don't know.
Okay. Sharang. Sharang has got the right answer.
The answer is 2.
Yeah. So basically, अभी just मैंने बताया था ना, other than mole you need 2 properties so that you can get all the other properties if you are having a system which is having 1 component and 1 phase, है ना? Is it okay? Clear ना? अभी just बताया था ना, you can have a system with 1 or more component and with 1 or more phases, and we have learned one part which is relevant to us. Other than that, वो graduation and post graduation की theory है, जिसमें वो पूरे detail में पढ़ते हैं. How many components and how many phases are there? So how many properties you need to get all the other properties other than mole? Then there is a formula for that which is not in your syllabus. तो उधर नहीं जा रहे अपन. लेकिन if I am having a 1 component and 1 phase system ना, so if I get just 2 properties other than mole, then I can get all the other properties. Like I told you, for an ideal gas, if I'm getting N, P and V, then I can get temperature, I can get all the other properties like internal energy, enthalpy, entropy, free energy, all these things we can get. No? So that's one part. Okay, next. Properties are also called
State function.
state functions or state variables. है ना? Okay. So because their value is required only information about the initial and final states. है ना? And they are required to define the state of the system. है ना? At present, at a given instance, what is the state of system, for which we need to define all these properties of the system. है ना? That's why they are called state function or state variable. What are the two things which are called non-properties or path function or path variable?
Heat and work.
Very good. So we have got heat and work. These are non-properties or path function. Why these are non-properties or path function? I'll let you know. बाद में पूरा topic discuss करेंगे. But the question I want to know now again is this. Tell me the answer.
Mole
बोलते जाओ mole.
extensive.
Mole is extensive है ना. It depends on the size of selection. आधा room कर दिया तो आधे mole हो गए ना.
Volume be extensive. Pressure intensive.
Volume is also extensive. Pressure is
Intensive.
okay. We'll discuss that. We'll discuss that. अभी के लिए मैं रहने देता हूँ. बाद में मैं तुमसे दो टाइप के explanation मैं दूंगा and then I'll ask you whether pressure is extensive or intensive. What about temperature?
Intensive.
It is intensive. I am writing for intensive and extensively I am writing E. Mass?
Extensive.
Okay. What about density?
Intensive.
It is mass upon volume. So extensive का ratio will be intensive. So this is intensive है ना. Internal energy.
Extensive.
Extensive. अभी ये जितने टर्म हैं ये हम लोग सीखेंगे बाद में. अभी के लिए जान लो कि these are extensive properties. Okay. Now you tell me molar volume.
Intensive.
Very good. Heat capacity.
Extensive.
It is extensive actually. बाद में हम लोग इसको पढ़ेंगे डिटेल में. Molar heat capacity.
Intensive.
Intensive.
No, it is intensive because heat capacity is extensive. Mole is extensive. So heat capacity upon mole will become intensive. Specific heat. It is again heat capacity
Intensive.
per unit
Intensive.
mass. So heat capacity extensive, mass extensive. So specific heat intensive. Molar enthalpy.
Intensive.
Intensive. Molar entropy.
Intensive.
Molar free energy.
Intensive.
Internal energy per mole.
Intensive.
Last
Refractive
three are
index.
intensive.
Intensive.
It is intensive है ना. ग्लास का छोटा टुकड़ा ले लो या बड़ा टुकड़ा ले लो. It will have a fixed value of refractive index है ना. Color
Intensive.
intensive for a homogeneous system. मैंने आधा पत्ता लिया या पूरा पत्ता लिया. It is having a green color है ना. Identical if it is a homogeneous system. Concentration
Intensive.
intensive again है ना. एक चम्मच शरबत पियो या फिर पूरा ग्लास शरबत पी लो. मिठास sweetness will be same. Sugar का amount will be different. So amount of sugar will be an extensive property, but concentration of sugar will be an intensive property. Now let me ask you this question.
That is viscosity intensive or extensive?
Viscosity is intensive only, है ना? Okay.
सर कलर क्यों इंटेंसिव है?
कौन कौन सा
कलर
कलर लाइक आई एम हैविंग. मान लो तुमने कोई भी एक कोल्ड ड्रिंक देख लिया ना. लाइक इट इज लाइक कोई भी रेड वाला ले लो. लाइक कोई भी फैंटा ले लो है ना. फैंटा आधा बोतल लो या पूरा बोतल लो. इज इट हैविंग सेम कलर और डिफरेंट कलर?
ओके सर गॉट
है ना.
सेम.
If you are not having the value or the explanation of the property depending on the size of selection, then it is intensive है ना. Okay, let's
Yes.
talk about pressure. चलो तो प्रेशर की बात करते हैं. I'll give you an explanation. तुम लोगों ने डाल्टन्स लॉ ऑफ पार्शियल प्रेशर तो पढ़ लिया है ना.
Yes, sir.
Now मान लो if I'm having mixture of N2 and O2, if I'm having a mixture of N2 and O2, so can I write P of mixture will be P of O2 plus P of N2? लिख सकते हैं ना. Partial pressure of O2 plus partial pressure of N2 becomes the total pressure of the mixture. That was Dalton's law of partial pressure है ना. ये एडिशन जैसा काम तो हम लोगों ने एक्सटेंसिव में किया था ना.
Yes.
So should the pressure be extensive property?
Sir, but अगर we take a container, तो throughout the container pressure तो equally होगा.
Okay, so that's the second part that says pressure should be intensive. Now, what answer is wrong?
According to me, pressure should be extensive because of the partial pressure thing, and secondly, like if we have to compress a certain amount of a gas, you will require more pressure to compress a larger amount than a small.
No, that we are defining the pressure of the system.
Oh,
Okay.
okay.
Whenever we are defining some property, it is defined for a system, है ना? So when we say the pressure of some gas inside a container, it has the same value throughout the container, है ना? Or even if I divide the room into half part, क्या बोलोगे? Pressure आधा हो गया क्या? ऐसा नहीं बोलते ना? Pressure is same ना? अदरवाइज मान लो अगर प्रेशर एक्सटेंसिव होता तो मैं रूम का एक छोटा सा टुकड़ा ले लूंगा ना, एक स्मॉल पार्ट, स्मॉल वॉल्यूम ऑफ रूम ले लूंगा, तो इट शुड हैव एक्सट्रीमली लो प्रेशर ना, फिर तो अपना बॉडी का ब्लड सब निकल जाता बाहर, बिकॉज इनसाइड आवर बॉडी देयर इज some pressure and outside if you are getting a very small pressure then the pipes all body का जितना पाइप है सब बस्ट कर जाएगा, ब्लड विल बी कमिंग आउट. तो इतना समझ में आ रहा है कि प्रेशर एक्सटेंसिव तो नहीं हो सकता है ना. Or if I say at a given point inside the room pressure is 1 atm, let's discuss that part. If I double or triple or 4 times or 10 times for the complete room मैंने ले लिया तो प्रेशर तो ह्यूज हो जाना चाहिए पूरे सिस्टम का फिर, and that is not the case ना. We say that the पूरे रूम का pressure is 1 atm है ना. If we define the pressure of the system, we define it for every point है ना, every point पे we say that the pressure will be 1 atm only. But when I say this thing, what is the wrong in this explanation then? यहाँ तो मैंने ऐड करके निकाला है और एडिशन का काम तो हम लोगों ने एक्सटेंसिव वाले में किया था. Then why I'm saying कि
सर वो
extensive-
2 phase 2
Sir,
component
system-
वाला है.
नहीं ना, अभी भी मान लो एयर भी है ना, इट इज अ मिक्सचर ऑफ गैसेस, स्टिल ऑल ऑफ इफ व्हेन ऑल ऑफ दीज आर कंसीडर्ड टू बी ideal gases, we don't see the identity of the gas while defining the pressure, है ना. Identity of the gas is not important, है ना.
Sir,
That's why
system
still if it is a mixture of ideal gases na, that can be treated as one component only if it is a mixture of ideal gases. Okay, what is the wrong part in this explanation? ये equation तो wrong नहीं है, नहीं तो फिर अपना gases state तो बर्बाद हो गया, क्योंकि वहां पर तो कितनी बार यूज किया ये काम, तो ये लिखना तो wrong नहीं है. But why this is not the explanation of pressure being extensive property? Why this is not the right explanation?
Sir, the system is different.
System is
Different.
नहीं ना, system is the mixture of N2 and O2. System is mixture of N2 and O2. ध्यान से देखो जरा ऊपर जो मैंने किया था ना, when I have written this statement, ये जो values था ये किस चीज का values था? Different compartments में उस properties का value था. So when you are trying to decide whether a property is extensive or intensive, you need to divide the system into compartments, not into different components or substances. Okay, when I'm saying P of mixture is P plus P of O2 plus P of N2, nothing is wrong in that, but based on that we cannot give the logic of pressure being extensive or intensive, है ना? While defining that or while doing the determination whether the pressure is extensive or intensive, don't do this job, है ना? This job is not relevant for this determination. Okay, this is the right statement, but this is not the right kind of right way of defining or right way of determining whether a pressure is extensive or intensive. For that we need to divide it into compartment again, and every compartment will have same molar ratio of O2 and N2, है ना? And that's why it will have same pressure in all the compartments, and that's why pressure is still intensive property. Is it okay? Clear? Hai? When I'm writing pressure of mixture is pressure of O2 and N2, I'm dividing the system into components, है ना? And not into compartments. Okay, and that's why this should not be the explanation for the to get the basis of pressure being extensive or intensive. This is the wrong basis shown. You know? So this statement is not wrong, but this is not. This should not be the explanation of the determination for the pressure being extensive or intensive. Is it okay? Any doubt up to this point? So next question is about what you had asked. ये सब कर लोगे तो अपने आप समझ में आ जाएगा what I am talking. जो करना है कर लो आप. बताओ जरा एक एक करके.
वाला इंटेंस.
फिर से ध्यान से देखो एक एक करके. You can't say the blank statement. Extensive upon extensive. What will it be?
Intense.
Intensive. Intensive upon intensive.
Intensive.
It will remain intensive because intensive का कोई भी combination आ जाए ना, so that is always intensive, है ना? क्योंकि every part of it was not depending on the size of selection, है ना? And that's why the overall property will also not be depending on the system or the size of selection inside the system. And that's why जहाँ सिर्फ intensive दिखे, like यहाँ देखो, यहाँ पर we have got intensive and intensive. We'll write intensive here. यहाँ पर देखो यहाँ सिर्फ intensive दिख रहा है सब. Intensive plus minus intensive into intensive. That is definitely intensive. But we need to be cautious if I am getting a combination of extensive and extensive or extensive and intensive. Like next question, बताओ जरा. What will the answer?
Extensive.
It will be extensive because numerator में we have got proportionality of size of selection. Denominator में it is independent. So overall it will be proportional to size of selection only. What about the next one?
Intensive.
Extensive.
Extensive. Not extensive.
So it won't be proportional to anything, right?
It will be inversely proportional to size of selection, and that was not the criteria for property being extensive. है ना? So we'll write it is neither extensive nor intensive. Understood now?
Yes.
When I am writing intensive upon extensive, so we are saying it will be some constant only in terms of size of selection. So it is not going to depend. It will have another constant into size of selection. Size of compartment I'll write. And that's why overall this thing is becoming, it is depending, but it has to be directly proportional, not the inversely. But here it is coming inversely proportional to the size of compartment. And that's why we'll say it is neither intensive nor extensive. What about extensive into extensive?
So it will be neither. That's neither.
Again neither nor, because it will become proportional to size of compartment का square, है ना? We'll say none. That means neither extensive nor intensive. Is it okay? ये समझ में आया ना? This
Yes.
will become proportional to size of selection का square, which is not the criteria. I told you many times that it is mathematically directly proportional to size of selection. It should not be size of selection का raised to 3 or 4 or 2. It has to be directly proportional to size of selection raised to 1. Okay, extensive into intensive. It will remain extensive, है ना? Is it okay? Intensive into extensive, again extensive, वही same question है, उल्टा लिख दिया से. What about extensive plus minus intensive? It will be none because तुम common ही नहीं ले पाओगे ना. It is like some constant into size of selection plus minus another constant. So it is not directly proportional to the size of selection, है ना? You are not having that common ले नहीं सकते. What about extensive plus minus extensive?
Extensive.
It will remain extensive. Is it okay? And what about this one?
So I had one doubt in the previous one, the extensive plus or minus intensive.
Okay.
So, sir, if like there's a constant into the size of selection plus any other constant, so what? So, like when won't it be directly proportional to the size of selection? Like when the size of selection increases, the property will increase, right?
It will increase, but it will, if we are doubling the size of selection, the property will not be doubled exactly. You know? It will increase, but it will not be doubled. You know?
Oh, it's like if
That's
the
why
size.
we are saying it will neither be extensive nor be intensive. You know?
Okay, sir. So for any extensive property, it has to be like this that if the size of
Mathematically, it has to be proportional to size of selection raised to 1. Okay.
Okay, sir.
That means if this is doubled, this should also be doubled. That is not the fact here. Huh?
Yes, sir.
Okay, what about this one? Extensive plus minus intensive into
extensive.
That's extensive.
Okay,
Extensive.
let's see that. ये ब्रैकेट वाली चीज क्या लग रही है? क्या हो गया ये?
Extensive होगा.
This has become extensive. And अभी just थोड़ी देर पहले पढ़ा था, if I am having extensive plus minus extensive, it will remain extensive only, है ना? Like I am going to teach you, enthalpy is defined, it is expressed by H, which is U plus PV, and V is volume, it is extensive. अभी जस्ट हम लोगों ने प्रेशर पे डिस्कशन किया है, it is intensive. तो intensive into extensive becomes extensive, and this is internal energy, that is also extensive. This is extensive. So definitely extensive plus intensive into extensive will remain extensive, and that's why this is also extensive force. Similarly, we have another property that is called free energy. Free energy is expressed by G, which is H minus T into S. This is entropy, which is extensive. ये सब पढ़ेंगे आगे, अभी घबराना मत नाम सुन के. This is temperature, which is intensive, है ना? And this is enthalpy, अभी just ऊपर किया हम लोगों ने. This is extensive. So now we have got extensive minus intensive into extensive. That will remain extensive, and that's why this will be extensive only. Is it okay? Any doubt up to this point?
So फिर वो चेंज का क्या होगा dy by dx?
क्या मतलब डिफरेंशिएट करना चाह रहे हो? Differentiate with
differentiate.
respect to what? That will decide the value.
Sir, like
We are
मतलब
differentiating an
ratio के जैसे ही
extensive
रहेगा ना,
property.
but वो
Okay, I'll tell you. This is also ratio kind of thing, ना? See ना? अगर मैंने बोला du by dt, then again this is extensive and this is intensive. क्या हो जाएगा? The ratio will remain extensive. And आगे जाकर मैं बताऊंगा, जैसे ये du by dt लिखा है ना, this is called capital CV, which is heat capacity at constant volume, which is extensive property. Okay, but यहीं पे अगर मैंने ऐसा लिख दिया ना 1 by n du by dt, now ये क्या होगा बताओ? Extensive और intensive?
चंदन
क्यों? du by dt क्या था? Extensive ना?
हाँ sir, but
N is
moles is
mole, that
inverse.
is also extensive, so this will become intensive. है ना?
Oh
Is it
yeah,
okay?
sorry sir.
Clear ना? Is it okay?
Yes sir, yes.
Chala. Okay. So basically, these were the discussion regarding if they have given you some property and they are asking you whether it is extensive or intensive, like refractive index, color, concentration, all of these are intensive properties. But जो अपने chapter में पढ़ने वाले हैं, without using the prefix molar or per unit mass suffix आ जाए कहीं, उसके बिना, if I am learning about internal energy, enthalpy, entropy, Gibbs free energy or simply free energy, all of these are extensive properties. Okay, temperature is intensive, pressure is intensive, mole and volume are extensive, mass is extensive. Okay, so this was one type of discussion. Another part is now अभी just जो हम लोगों ने पढ़ा है ना, क्या क्या पढ़ लिया, we'll be having a system may be open, closed or isolated, that's one part. Now system will have some property mainly can be divided into two forms. Not all the properties are extensive or intensive, because we have got some result which was saying neither extensive nor intensive also, है ना, so those properties can also be there. Practical example कम मिलते हैं, जबरन बनाई हुई property हो सकती है, like मैं बोल दूं mole per unit volume, so we'll say it is neither extensive nor intensive, है ना, so that's another kind of thing. But normally we are saying, जैसे यहाँ पर भी इसको I'll write that it is again extensive, है ना. So now what I was saying कि I am having a system which can have different types. That system can have properties. Properties are also called state functions or state variables. Properties can be changed during a process, है ना. If the system is undergoing change of one or more property, that change is called a thermodynamic process. So in whatever manner system is changing its state by changing its one or more properties, it is called a thermodynamic process. So set of all properties associated with the system at a given instance is called state of system at that given instance. When I am talking about a thermodynamic process, it is the change of state, that means change of one or more properties of the system from one equilibrium state to another equilibrium state. Now, how many processes we can have? How many processes we can have? Okay.
So how many processes?
A system can undergo how many processes?
There different conditions will start being constant.
Okay, so basically I am telling you, मान लो एक system का pressure, initial pressure was 1 atm, final pressure is 2 atm. Now, how many processes it can follow to get from 1 atm to 2 atm? Infinite है ना. हो सकता है मैंने वॉल्यूम कांस्टेंट कर दिया हो सकता है मैंने टेम्परेचर कांस्टेंट कर दिया हो सकता है मैंने वॉल्यूम इनटू टेम्परेचर कांस्टेंट कर दिया हो सकता है मैंने सबको वेरिएबल रखा हो, है ना. So that can be that can have infinite ways, है ना. And that's why if they are asking you how many thermodynamic processes can happen with the system or can undergone by a system, we'll say infinite. There are few important or few easy process which are in our syllabus, and that's why we are going to see them in detail. So there can be infinite thermodynamic processes. Following are some important thermodynamic processes. Okay, I'm not saying these are the only processes. Following can be some important thermodynamic processes. Like if I'm having isobaric process, that is explained by the sentence that pressure has to be constant throughout the process. Now I'll be showing you three kind of processes. I'm showing it by PV graph. मान लो अपने पास 1 mole of some ideal gas is there, and I'm just showing you three graphs. P versus V. Assume that the system was at this state, and this is like 180 ampere, and it has undergone a process like this. यहीं पे मान लो 180 ampere, and system has undergone a process like this, and this is at 1 atm, and system has undergone process like this. Okay, मान लो ये state A है, state B है, state A, B, A, B. If I ask you, what is PV minus PA? How much is PV minus PA?
0.
0. What is PV minus PA here?
0.
0. What is PV minus PA here?
0.
So we have got a delta P, that is change in pressure here is 0. Again, delta P in this process is also 0, and delta P in this process is also 0. Can we say all these three are isobaric, or only one or two processes are isobaric?
Sir, only the last is isobaric.
And why not first and second?
So because the definition states that throughout the process, right? So,
Okay, that means, but we are saying that delta P is 0.
but it's like state function ना, हमें path
Yes, yes.
function
So
जैसा treat
initial
है.
and final are same, but बीच में this is changing its pressure, है ना? And that's why even if delta P is 0, that doesn't give you the guarantee that the pressure will be, the process will be isobaric. We'll be saying it is not isobaric. These two processes are not isobaric, as dP throughout the process is not 0, है ना? During the process pressure is changing, है ना? पहले बढ़ रहा है फिर कम हो रहा है, तो it is not constant. It has to be constant throughout the process, then only we'll call it isobaric. Only by saying that initial and final pressure is same, it doesn't give you the guarantee that the process is isobaric, because the process may or may not change during the process. But if I say the system is undergone a process at 1 atm, then definitely we are saying throughout the process the pressure was 1 atm, then it is isobaric process. So we are saying this is isobaric as dP is equal to 0 at every state during the process. Is it okay? Any doubt? So if you have understood this, so we need to ensure that when I'm saying isobaric process, we need to ensure that pressure has to be constant. That means dP has to be 0 at every point. Only delta P0 will not ensure, but that will also be 0 if dP is 0, है ना? तो यहाँ पे हम लोग बोल रहे हैं दिस इज आइसोबैरिक, यहाँ पे dP 0 है तो डेल्टा P भी 0 होगा, है ना? That is also a result, but that is not ensuring that delta P0 होना is not ensuring that the pressure will be, the process will be isobaric. Is it okay? So in the similar way, we can have different kind of processes, like I can have isochoric process, लिखते चोरिक है बोलते कोरिक है. So in that also dV has to be 0. That means volume remains throughout the remains constant throughout the process. Then only we'll call it isochoric. वैसा ही there is third process which is called isothermal process. उसमें क्या रहेगा? Pressure will, temperature will be constant throughout the process. Then it will be called isothermal process. There is a fourth process which is called adiabatic process. Now that is saying that heat should not be exchanged at all during the process. Then it will be called adiabatic process. Is it okay? एक लास्ट प्रोसेस है, दैट इज कॉल्ड साइक्लिक प्रोसेस. साइक्लिक का मतलब क्या? जहां से चले वहीं पे आ गए. which means if the final state is exactly same as the initial state, final state becomes exactly same. When I say state, that doesn't mean only one or two property, all the properties should exactly be same, then only say the process is cyclic. Okay, so then it is called cyclic process. Now if I am having some cyclic process and if I ask you what will be the delta of V, क्या कहोगे? अगर ये फाइनल स्टेट इज एग्जैक्टली सेम है, सेम एज इनिशियल स्टेट, तो किसी ने पूछा साइक्लिक प्रोसेस में डेल्टा V क्या होगा? व्हाट कैन यू से?
0.
0. डेल्टा P क्या होगा?
Also 0.
A will 0, delta T will be 0, delta N will be 0. Whatever property I am talking about, delta of any property or state function will be 0, है ना? will become 0. Okay, so this thing we are going to use. So when I say delta of any property or state function will be 0, तो जो प्रॉपर्टी का डिटेल अभी तक नहीं पढ़ा है उसके लिए भी बोल सकते हैं, बिकॉज वी नो दैट दोज आर द प्रॉपर्टीज ऑफ द सिस्टम. एनी प्रॉपर्टी इक्वल 0, तो इसका मतलब जो नहीं पढ़ा है डेल्टा यू अभी तक नहीं पढ़ा है, बट वी कैन से डायरेक्टली डेल्टा यू विल बी 0. डेल्टा एच नहीं पढ़ा है एच क्या होता है, बट वी नो दैट इट इज अ प्रॉपर्टी, सो डेल्टा ऑफ एच विल बी 0, डेल्टा एस विल बी 0, डेल्टा जी विल बी 0. ऑल ऑफ दीज आर प्रॉपर्टीज, तो डेल्टा ऑफ दीज प्रॉपर्टीज विल बी 0. अब इसी को क्या करेंगे ना, दे विल गिव यू इन डिफरेंट वेज. So when I say delta of any property is 0, just to confuse you, sometimes ये जो delta of any property है ना, इसको बताने का एक दूसरा तरीका होता है, ऐसा इंटीग्रेशन लगा देंगे, ठीक है, डराने के लिए, एंड देन d of any property लिख देंगे, और फिर क्या करेंगे, यहां पर एक सर्कल मार देंगे. What does it mean? It means integration over closed path. To integration over closed path for any property will become also 0. It means same. इसी को क्या करेंगे ना, they will define a process, like बोलेंगे A से चला, B गया, C गया, वापस A आ गया, and then they'll write D of any property. क्या बोलेंगे? Again that will be 0 during this year. तो ऐसा कुछ भी बोलेंगे वो, जैसा जो पेस वाले हैं उनके मॉड्यूल में एक क्वेश्चन है जिसमें उन्होंने ऐसा ही किया, डेल क्यू रिवर्सिबल बाय टी का इंटीग्रल भी नहीं दिया, समेशन ऐसा दिया हुआ है, समेशन ए टू बी टू सी टू ए ऐसा लिखा हुआ है, और इसका वैल्यू पूछा है क्या होगा. एंड ध्यान से देखो जरा, ये ए था एंड लास्ट में भी है. व्हाट डज इट मीन? व्हाट डज इट मीन?
Process.
इट इज अ साइक्लिक प्रोसेस. एंड नाउ ये जो समेशन के बाद लिखा है ना, दिस इज द डेफिनेशन ऑफ डीएस. So that means they are asking you what will be this, that is 0, है ना. उन्होंने एक साइक्लिक ग्राफ बना के दे दिया और ऐसा एक समेशन डेल क्यू रिवर्सिबल बाय टी पूछ दिया, एंड डेल क्यू रिवर्सिबल बाय टी इज द डेफिनेशन ऑफ डीएस. So they are simply asking you integral ds over closed path, है ना. That means साइक्लिक प्रोसेस में ds का समेशन क्या होगा, that is 0. Simply 0 रिपोर्ट कर देने का. Any doubt up to this point? So again we'll do some question, and then next day we'll talk about these processes can be carried in different manners. But उससे पहले जितना सीखा है उसको जरा अप्लाई कर लेते हैं. बताओ जरा, बताओ जरा, ये 0 होगा क्या?
Yes, sir.
Okay.
Yes.
What about this one?
Yes.
Yes.
Yes. What about this one?
Yes.
Yes.
What about this one?
No.
No, because dt बोला है, हो सकता है बीच में चेंज हो रहा हो. फाइनल इनिशियल सेम हो गया, इसका मतलब ये नहीं कि बीच में भी सेम रहा होगा, and that's why dt may or may not be 0, है ना. That's why if they are asking you it is always 0, you will not report it. ep
No.
will not report it. Delta u,
Yes.
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 just बोलो, ऊपर दिख भी रहा है. Delta h,
Yes. Sir.
Yes.
yes. Delta s,
Yes.
Yes.
very good. Delta g,
Yes. Sir.
q is heat. Q is heat.
No, sir.
नहीं ना, heat was a path function, है ना, तो will not report it. W was work.
So
No.
no.
No, है ना. What about integral ds over closed path?
Yes. Sir.
Yes.
Yes.
Just बताया मैंने, this was 0 during the process, है ना, cyclic process. What about this one?
Yes.
Yes,
Yes.
because g was a state function or property, and summation फिर से देखो a से लेकर a पे आया है, a से c पे नहीं आया है, a से b से c पे वापस a पे आया है. That means they are talking about cyclic process, है ना, and that's why this will also be 0 definitely during a cyclic process.
Sir, just a question.
Yeah.
So in the last one, instead of dg, if they would have said any path function like dq or dw, then what would have we said?
अगेन नॉट नेसेसरली जीरो, है ना.
Okay, sir. So, sir,
तो
for
नहीं लिखते हैं, दे राइट del Q और del W, है ना.
okay, so if they write like for heat or for work, then we won't mark that, right?
No, for cyclic process, it may or may not be zero. We are not giving the guarantee, है ना. It is asking, the question is asking whether it will be always zero. We'll say no.
Okay, sir.
It is possible that in few cyclic processes, net work done may be zero also, but it is not necessarily zero, है ना.
Okay,
I
sir.
can create a cyclic path in which the net work will also be zero, but it is not definitely going to be zero in all the processes. Okay.
Yes, sir.
So,
हाँ जी.
in integral का वो symbol, what is that zero in the between?
जीरो नहीं है वो, ऐसा होता है, दिस इज इंटीग्रेशन ओवर क्लोज्ड पाथ, ऐसा होता है. तो क्या है, वर्ड में ऐसा मिलता नहीं साइन, तो वो इसको ऐसा ही रिप्रेजेंट कर देते हैं, ऐसा गोला डाल के, बट इट इज एक्चुअली लाइक दिस.
Okay.
इट मींस इंटीग्रेशन ओवर क्लोज्ड पाथ. क्लोज्ड पाथ, क्लोज्ड पाथ कौन से प्रोसेस में मिलेगा? साइक्लिक प्रोसेस. तो थर्मोडायनेमिक्स में इट मींस साइक्लिक प्रोसेस. ओके. ए से वापस ए तक जाने के लिए साइक्लिक बनाना पड़ेगा ना, क्लोज बनाना पड़ेगा ना.
Yes, sir.
ओके, दैट्स वन पार्ट. एक और क्वेश्चन आता है जो बच्चों के लिए काफी डिफिकल्ट हो जाता है, बिकॉज इफ यू सॉल्व एनी मॉड्यूल ना, किसी का भी एलन पेस किसी का भी मॉड्यूल ना, वन प्रॉब्लम व्हिच इज फेस्ड बाय मोस्ट ऑफ द स्टूडेंट्स आर, बच्चे लेके आएंगे सर ये क्वेश्चन में पता ही नहीं चल रहा है प्रोसेस कौन सा है, मैथमेटिक्स कैसे लगाएं और थर्मोडायनेमिक्स अप्लाई कैसे करें, है ना. कई बार सेंटेंसेस लिखे रहेंगे और सेंटेंसेस को देख के पता ही नहीं चलता है. तो वी नीड टू आइडेंटिफाई, वी नीड टू लर्न हाउ टू आइडेंटिफाई वेदर अ प्रोसेस इज, मतलब हाउ टू आइडेंटिफाई प्रोसेस किस टाइप का है, वेदर इट इज आइसोबेरिक, आइसोकोरिक और आइसोथर्मल और आइडियाबेटिक या साइक्लिक क्या है. वी नीड टू अंडरस्टैंड दैट देयर आर फ्यू कीवर्ड्स. ओके, तो आई विल राइट दैट name of process and what can be the keyword used in the questions, है ना. So name of process and then keywords or hint given in question. अब एक तो देखो क्या है कि they'll be directly using in an isothermal process, ऐसा लिख दिया तो we know already कि that is isothermal, है ना. But if they have not written isothermal word, then how they are going to give you the English words by which we can identify whether a process is isothermal, isobaric क्या है. तो सबसे पहला, if I am talking about isobaric, isobaric का मतलब प्रेशर कांस्टेंट होता है ना. प्रेशर कांस्टेंट करने का सबसे अच्छा तरीका क्या है ना, जस्ट कीप द वेसल ओपन. इफ इट इज एन ओपन वेसल ना, तो इस प्रेशर विल बी इक्वल टू द एटमॉस्फेरिक प्रेशर, है ना. So that's why if they want you to know ना कि प्रोसेस आइसोबैरिक है, वो ओपन वेसल या कंटेनर लिख देंगे. ओके, इसका मतलब ही है P ऑफ सिस्टम इज इक्वल टू ऑलवेज P ऑफ एटमॉस्फेयर. Okay, so this is the first keyword you will be getting in the question. Second, if they want you to know कि process is isocoric, अगर उन्होंने कांस्टेंट वॉल्यूम नहीं लिखा, आइसोकोरिक का मतलब कांस्टेंट प्रेशर होता है. वैसा ही आइसोकोरिक का मतलब कांस्टेंट वॉल्यूम होता है. इफ दे हैव नॉट यूज्ड द डायरेक्ट वर्ड आइसोकोरिक और कांस्टेंट वॉल्यूम, व्हाट काइंड ऑफ वर्ड दे कैन यूज, क्या करने का है, सील्ड और क्लोज्ड. रिजिड कभी कभी लिखेंगे भी, कभी कभी नहीं भी लिखेंगे, बट वी नीड टू फाइंड आउट कि मान लो कंटेनर लिखा है ना, एंड दे हैव नॉट गिवन यू सिस्टम लाइक बलून वगैरह जिसका वॉल्यूम चेंज हो सकता है, तो फिर वो नॉर्मली भी सील्ड या क्लोज्ड कंटेनर या ट्यूब ऐसा कुछ लिख देंगे, तो भी समझ में आ जाएगा कि दे आर टॉकिंग अबाउट आइसोकोरिक. बट मान लो अगर तुमको एक बलून दे दिया विच इज क्लोज, इवन देन द वॉल्यूम इज नॉट कांस्टेंट बिकॉज बाउंड्रीज कैन एक्सपैंड, है ना, और कॉन्ट्रैक्ट. फ्लेक्सिबल वॉल्यूम्स आर देयर, है ना, बाउंड्रीज आर देयर, एंड दैट्स व्हाई वहां पे हम लोग आइसोकोरिक नहीं लेंगे. बट इफ दे आर सिंपली सेइंग a sealed container is having a gas or 1 mole of an ideal gas, ऐसा कुछ बोल रहे हैं, they are talking about isocoric process, and piston should not be there. without piston, without movable piston, क्योंकि sealed होने के बाद भी if piston is moving, volume is not constant. Third one is if I'm talking about adiabatic. Adiabatic में क्या था? Heat was not exchanged, है ना? What can be the keyword? It has to be insulated, है ना? Okay. Fourth one is isothermal. सबसे टफ इसी का रहता है क्योंकि इसमें कोई वर्ड नहीं रहेगा. I'll show you some of the examples. Next day उसको करेंगे डिस्कस. इसमें क्या टेम्परेचर हैज टू बी कांस्टेंट, है ना? उसके लिए क्या करेंगे ना, they'll give you the complete description of the process. Some temperature like at 25 डिग्री सी. पूरी कहानी बता देगा और लास्ट में लिख देगा at 25 डिग्री सी. ओके, then definitely they are talking about an isothermal process. and एक लास्ट है जो साइक्लिक पढ़ा है हम लोगों ने. साइक्लिक का मतलब है या तो वो ग्राफ देंगे, a closed graph will be given, or final state will be given exactly same as the initial state. And when I say a final state, it doesn't mean only one property. Final temperature is same as initial temperature. That doesn't mean you have got the same state. If I am having one component, one phase system, at least two properties other than mole should be same. है ना? Then only you say final state is same as the initial state. Is it okay? Any doubt?
So I just had two questions.
Ah.
So in the isochoric process you've written without movable piston. So sir, along with the volume, the pressure also won't change, right? Because
No, pressure can change. If I'm giving a heat to the system, definitely
yeah.
the pressure will be changed, है ना?
Oh yes, okay, sir. And so
Because
in the
pressure depends on volume as well as temperature, है ना?
yes,
The volume is not changing, but temperature may be changing, है ना?
yes, sir. So and in the adiabatic process, so will it only take place for an isolated system because there's no heat exchange with the
Okay, I have not written isolated, but I have written insulated. Isolated हो गया तो there is no exchange of any form of energy. But when I write insulated, then definitely heat is not being exchanged, है ना?
Oh, okay, sir. So in adiabatic, like other forms of energy can be exchanged.
हाँ जी, हाँ जी.
Okay, sir.
Okay.
So can you please explain this like exactly same as the initial state? वो नहीं समझा.
अभी जस्ट मैंने बताया था ना, मान लो if I am having a graph, ऐसा बोल दिया कि the initial form was initial 1 atm and 20 liter volume was there. यहाँ से फिर it has gone to some 2 atm and some volume B2, ऐसा कुछ गया है. और ऐसा करते करते and then ultimately they are saying it has come to 1 atm and 28. What does it mean? They can give you a series of processes, but the final state must be exactly the same as the initial state. Then it is a cyclic process. No?
And sir, what about phase?
Huh?
Like water
Phase
gaseous
they are not
to
going to
liquid.
change in this case. Cyclic process में they are not going to change the phase itself. Phase change हो गया तो भी state is not same, because that will have another set of properties, है ना?
Okay, sir. So मतलब only this state.
नहीं वैसा तो normally देखोगे you will be dealing with most of the time in these cases you will be dealing with an ideal gas, है ना? So they're not going to deal with the phase change for the ideal gas. Definitely not in this case, है ना? So normally you will be dealing with ideal gas system for these processes. Okay.
Okay, sir.
Okay. So now next day, what we are going to do, we'll be doing one more important discussion, and that is about manner of carrying these processes or any other process in two manners, which are called reversible and irreversible manner of carrying the processes. And we are going to go into the detail of this thing क्योंकि बच्चे यहाँ पे confuse हो जाते हैं. That's why we'll have a detailed discussion over this topic, and then we'll dealing with some of the questions जो मैंने अलग से तैयार कर दिया. I'll be giving you sentences used in the question, and I'll ask you to identify what kind of process is there and in what manner it has been carried, reversible or irreversible. Okay, तो ये दोनों कहानी जब कर लेंगे ना, then we'll learn first law of thermodynamics, and then we'll start applying first law of thermodynamics in all these processes, है ना? तो next class का maybe next class का आधा lecture will be again a theoretical discussion, but the remaining part will become mathematical totally. Once we are going to enter into the mathematics na, then it will be totally mathematical. आज का class was theoretical. Next class का half lecture will be again theoretical, and then we'll enter into the mathematical portion of the chapter. Okay, चलो ठीक है, आज का lecture फिर यही close करते हैं ना. Okay, चलो जी, bye. हाँ, एक काम करो ना, अगर एक दो डाउट है तो मैं फटाफट कर दूंगा because I am having another lecture also. ठीक है, तो अगर एक दो डाउट, हाँ क्विक डाउट्स हैं तो फटाफट बोल दो, है ना.